All right, I want to work an example um, with pressure. So let's consider an elephant and a woman. Now this elephant's going to be standing on all four of its feet. Okay, 4 feet with about a 30 centimeter diameter. Okay, and the woman will be standing on 2 feet. And let's assume she's in spike heels so that her weight is on a 1 centimeter diameter spike heel. Okay, now the elephant probably has a mass somewhere in the neighborhood of 2,000 kilograms. Actually, that's probably a little on the low side. Let's make it 4,000 kilograms. 4-ton elephant. And the woman, she probably has a mass somewhere in the neighborhood of, well, 50 kilograms is probably a little on the light side, but let's let her be light. Somewhere in the neighborhood of 50 kilograms. All right, so what is the pressure underneath each of their feet? Well, in the case of the elephant, the total force is 4,000 kilograms times the acceleration of gravity, which is about 10 meters per second squared. So that'll be 40,000 newtons. And each foot will take 1/4 of that, so the force per foot will simply be 10,000 newtons. By contrast, for the woman, she's got a force that's 50 kilograms times 10 meters per second squared will be about 500 newtons, and each foot will have a force of only 250 newtons. Well, that's hardly surprising. Women weigh less than elephants. Of course they've got less force on their feet. But now, let's consider the pressure. The area of the elephant's foot is pi times 0.15 meters squared. All right, so I have pi times 0.15 squared. Okay, so that's an area of 0.071 meters squared. The area under the woman's foot is just pi times half of 1 centimeter squared, 0.005, that's half of 1 centimeter. We square that. That's only 7.9 times 10 to the negative 5 meters squared. Much less. So if we consider the pressure, I've got 10,000 newtons divided by 0.071 meters squared for the elephant, which will be 1.4 times 10 to the 5, a little more than 1 atmosphere of pressure. These are newtons per meter squared, or pascals. Pressure under the woman's spike heel, oh, that should be less. It's only 500 newtons. Oh, but wait a second. I'm dividing by 7.9 times 10 to the negative 5 meters squared. Let's look at that. Okay, so I have 500 divided by 7.9 exponent 5 negative. Oh my goodness. That's 6.3 times 10 to the 6th. Pascals. So underneath the woman's spike heel, there is more than 40 times as much pressure as underneath an elephant's foot. It's not that she weighs a lot, it's that she's putting all of her weight over such a very small area. Even if we consider that maybe she has half of her weight on the balls of her foot instead of on the heel, we're still going to have much more pressure on the heel of the spike heel than we will underneath an elephant's foot. Interesting story, when they first opened Disneyland, the pavement was still a little bit soft, which would be fine for a large animal, but for a woman dressed elegantly in high heels, they often sunk into the newly laid asphalt and had to leave their shoes behind.